Hi, I'm Kayla, and in this video I'm going to be solving an optimization problem using basic calculus. So what we have is 300 meters of fencing to enclose a rectangular field. One side of the field is a natural embankment like a river, and we need to figure out what the maximum area is and what dimensions will result in the maximum area. So this is what I would draw out for this word problem. And because I'm looking for the area, that's the first equation I'm going to write out. So we know that area is length times width. In this case, it's x and y. And because I'm solving for the maximum area, and because this is calculus and an optimization problem, I know that the area is eventually what I'm going to need to take the derivative of. So before I can do anything with the area, I need to replace one of these variables. So this would be true no matter how you were solving it, whether it was calculus or grade 10 math. You would need to have just one variable, so either x or y. So the perimeter of this is 2x plus y. And I'm writing that down because they've told me that I have 300 meters of fencing, and I know that I can rearrange this to get rid of one of my variables. So I'll plug in 300 meters is equal to 2x plus y, and then I'll rearrange this for y, because that just makes it easy to plug in. So then I take this, I go back to my area equation, and I say area is equal to x times 300 minus 2x. And then I'll expand that. So I have 300x minus 2x squared. And that's my area equation. Okay. Now that I have that, I need to say, what am I looking for? Okay, I'm looking for the maximum area. So what kind of properties do I know about when the maximum occurs and what that looks like? So go back to this equation. This is telling you the area. This is a parabola, and it has a maximum because this -2 is my a value. This is just simple math again. If you rearrange this, this is my -a. And it's a negative value, so I know that my curve is facing down. So what this looks like here is like this. This is my curve, and I know that this is where the maximum of the curve is. So you should already know that when we're at the top of a curve like this, the tangent is horizontal, so it's 0. So because the tangent at any curve here, that's not my derivative, right? So when I take the derivative, what I'm really getting is the slope of the tangent. So of course, at the top of any curve, the slope of the tangent is completely horizontal, which is 0. And because my derivative, my a prime, is the tangent, I set my a prime to 0. So if I know that a prime is 0, then what I need to do next is figure out what a prime is and set it equal to 0. So my a prime is the derivative of this equation. So that's my first step. This is the first time I'm actually using any calculus that we've learned. So to take the derivative, this is following the simple rules. Whoops, no x, sorry. Just copying it. So it's going to be 300, and then minus 4x, and that's my derivative. Of course, the x gets dropped from the 300, and then the 2 is brought down in front, multiplied by the 2 gives you the 4x. And then because we know that we say at the max, a prime is equal to 0, so you have to state that. You say that 0 is equal to 300 minus 4x. Rearranging gives you 4x is equal to 300, and you don't even need to write that down, just write the final answer, x equals 75, which is of course 300 divided by 4. Okay, so now what we have is one dimension that will result in the maximum area. And why do I know that this dimension results in the maximum area? Because I just stated that the a prime is 0 at the max. I had the area equation here, I took the derivative, so this makes sense. Now because this area is obviously constrained by 2 x's and a y, I know that I can plug this x back into that equation and solve for y. So that's what I'm going to do. So when x is equal to 75, that'd be 300 minus 2 times 75 is equal to y, and y is equal to 150. So then I would say, therefore, my max area occurs when we have x is equal to 75 meters, y is equal to 150 meters, and then of course 75 times 150 would give you what the actual maximum area is. Okay, and that's it. Thanks for watching.